Hello, we're going to talk about linear transformations, and today we are actually going to be discussing reflections across the x or the y-axis, reflecting across the x or y-axis. So let me go ahead and underline that so that we can see that that is our title. Okay, we're going to start with a parent function, f of x equals 1/2 x plus 1. Now, to reflect over the x-axis, our new function, g of x, takes the form negative f of x. So in this case, our g of x would equal the negative of 1/2 x plus 1. Might be easier to graph if I distribute that negative, so that would be negative 1/2 x minus 1. Okay, first step, let's graph our parent function. So that is 1/2 x plus 1. So I'm going to find my intercept of 1. My slope is 1/2. I go rise 1 and run 2. So up 1 over 2, up 1 over 2. So graphing our parent function here, it's going to come cruising through like this. I'm just going to label this one f of x. And that is our parent. It's a function of x. G of x is negative 1/2 x minus 1. It's got a negative slope. So I'm going to come down to negative 1 for my intercept. And then it drops 1 before it runs 2. Negative 1 over 2. Or rises 1 and goes backwards 2. So we're going to go ahead and graph this line right here. This is our g of x. Now, if we take a look, we can see that this point reflected down here into the lower quadrant. This point reflects downward, so this reflected over our x-axis, and it intersects on the x-axis. That's going to be kind of a large clue that that reflects over the x-axis. The negative was in front. We are now going to reflect over the y-axis, and that equation takes a slightly different form. That one would be g of x equals f of negative x. So you make only the x term negative in our second function. So our t of x would equal 1/2 negative x, 1/2 times negative x, plus 1, or negative 1/2 x plus 1. Again, we see it as a negative slope. When we graph it, it crosses at the positive 1. The intercept is positive 1. And its slope is negative, down 1, backwards 2, or up 1, backwards 2. Okay, I'm sorry, down 1, forward 2. And we're going to have this equation right here. And I'm going to label that t of x. Now, I can see that if I take my parent function, this point translated over here, it reflected this direction. This point reflected over here, and they intersect on the y-axis, which would be further proof that it reflects over the y-axis. Have a good day.